Alright, write each of the following expressions in simplest radical form. Alright, so this is taking us back to geometry. Looking for perfect squares. The largest perfect square that we can think of that goes into 80. And the largest one that goes into 80 is, I believe, 16, right? 16 goes in. 5 times the square root of 16 is then 4 radical 5. Looking for the largest one that goes into 72, that would have to be 36. So we have 36 with 2 left over. So my final answer is 6 square root 2. You can never trap a perfect square inside a radical. But there are extras that can be trapped inside. So perfect square and then a non-perfect square. So 49 comes out, right, which is 7 square root 2. For 150, the biggest perfect square we can think of that goes into that is 25, I believe. And it goes in 6 times. And so that's 5 square root 6. And lastly, 300, the largest one that goes into that is 100. So that's the square root of 100 and the square root of 3. So 10 square root 3. Those are what we call simplest radical form for those particular square roots. We are going to be solving quadratic equations using the method of square roots. We need to know when I can use that and when I can't. When to solve a quadratic using square roots. The two options are no linear x term . Okay, or you already have a perfect square. And what do I mean by you already have a perfect square? Something like this. X plus 1 quantity squared. If you've got no linear x term, or you have a perfect square, then it's time to use the square root method. Let's take a look at some examples. So, as you can see, when you look through part A, no linear x. When you look through part B, no linear x. No linear x. Okay? No linear x. It's a little bit hard to see what's going on with E and F, so we'll just have to take a look at it when we get there. So, let's see here. We can push this to the other side. We don't have to set this equal to 0. We don't have to factor this thing. We're just going to subtract the 2 to the other side. And that gets me 21. And then we can divide by 3. Now, keep in mind here when we have x squared equals 7, that we are going to use the square root to get rid of the square. But I need to show you a picture. It's a picture of a parabola, but I got to draw one that actually looks like a parabola. And we have a horizontal line that comes through. Y equals 7. How many times does the horizontal line y equals 7 cross the parabola? Of course it crosses twice. There is a positive answer, and there is a negative answer. So when you solve this question, you must have both answers. You can't just have one. You have to have both. Now, when could you have less than 2 solutions? Well, if it said x squared equals 0, because then that would be right here at the bottom and there's only 1 there. What if it said x squared equals a negative? Well, now we're talking not possible, at least not with the reals, the numbers you're used to using. Alright, so let's see here. We're going to add 25 and move that over to that side, giving me 4x squared equals 25. We're going to divide by 4 on both sides, and then we're going to, so we have x squared equals 25 fourths. I suggest you leave it in. With these perfect squares, 25 and 4, don't change it. when you go to take your square root, just remember, you're square rooting everything, both the top and the bottom. So x equals plus and minus 5 over 2. If you leave it as a fraction, it'll be much easier to solve. Much easier to solve. Just leave it as a fraction. Don't make it, don't make it all weird. Next, add the 64 over to the other side. 2x squared equals 64. Divide out the 2. X squared equals 32. And yes. So we would, to finish this off, take a square root. And yes, of course, we're going to have plus and minus radical 32, but wait a second. That can be simplified. Like we can have plus and minus, we can bring a 16, which is a perfect square, out of that, leaving 2 trapped inside. So final answer, plus and minus 4 square root 2. Okay, so on this next one, once again, no linear term, so I'm going to push that to the other side. So, subtracting it. Now, we haven't talked about this, but that would go with my picture. Y equals -9 is down here. So, this would be no real solution. Because, as you saw in my picture, -9 doesn't even touch the parabola. So there's no answer to that, no real number solution answer to that question. We will eventually talk about that, but not as of yet. We will get to it. Okay, so here we're going to, this is a proportion, we're going to cross multiply. So that's 5x squared on one side and 80 on the other side. Once again, no linear term. Haven't come across that other situation I talked about. Divide by 5, x squared equals 16. Take the square root on both sides, and we get plus and minus 4. Don't forget your plus and your minus, because there's two solutions, a positive and a negative. So similar type idea here, 7x squared, and then 6 times 14 is 84, I believe. And so, just like that we did before, we don't have a linear term, so we're going to divide by 7. X squared equals 112. And so now we can take the square root of both sides. X equals plus and minus radical 12. I bet there's a perfect square that's trapped inside that. That is true. There is a plus and there's a 4 trapped inside, which means, and you can't keep a perfect square trapped inside of a radical. However, the non-perfect square, it definitely stays inside. Now, the other situation that we talked about was when you have things that are already perfect squares. All right, now, before we can get to the square root, we've got to get this thing isolated. So that means get it alone, right? So the 6 is going to come over. We've seen, oops, what am I crossing off that for? Crossing off this. Put that on the other side. That would give me 48. Then I divide by the 3, divide by the 3. Those cancel. X minus 2 quantity squared equals 16. Now I can take the square root like I've been doing before. And I get x minus 2 on this side because the square and the square root cancel each other out. And then on this side, I get plus and minus 4. Well, what does that create? Well, now there's two different equations. X minus 2 equals 4. X minus 2 equals negative 4. And so, add the 2 to the other side. X equals negative 2. That's one of the answers. Add the 2 to the other side. X equals 6. Two solutions for the question. All right, next one. So, trying to get the parentheses by themselves, so we're going to divide out the 2. So, 4x plus 3. Now, whatever you do, don't FOIL this stuff, because that would be a waste of time. All right, we're going to take a square root and get the square and the square root cancel each other out. 4x plus 3 equals plus and minus 8. So set up your two equations. 4x plus 3 equals 8. 4x minus plus 3 equals negative 8. Notice I didn't change the left side. The left side stayed the same. The left side looks like this. It's only the right side that changed. And then, of course, we're going to take away the 3. Take away the 3. 4x equals negative 11. 4x equals 5. And then we can divide by 4 on both of these. And we find out that our two solutions are 5 over 4 and negative 11 over 4. Not nice numbers. Not going to say they are nice numbers, but that's what they are. One more down here. This time I'm going to multiply both sides by 5, giving me x plus 1. This is kind of like cross multiplying was on the last couple examples. And then when I get to here, I take a square root. And the square root cancel. X plus 1 equals plus and minus square root 45. Now, there's a perfect square in that. I believe it's 9, which would leave a 5 trapped inside. So we have x plus 1 equals plus and minus. Well, the square root plus and minus, there's 3 and then radical 5. 3 and radical 5. So we're going to subtract a 1, subtract a 1. X equals negative 1 plus or minus 3 radical 5. Now, I'm okay if you leave both answers like that because you can't add them together. Okay, example 3, problem solving. We are back to the object being launched kind of questions, but something critical is happening here. The object is being dropped, which I mentioned in class previously. That automatically tells me that the middle term v equals 0. Well, that is reflected because notice that the term in the middle is missing. That's why it's missing, because the object was dropped. So we literally are starting up here at 270 feet, and it's dropping down to the ground. Now, keep in mind, this is time. This is not the path of the object. Literally, we could have stood at the edge of the building and dropped it straight down to the ground. So it doesn't have to be launched away from the building so that it's following a parabolic path. But on the graph, it would look that way. At least a time and height graph. Okay, so we sketched the picture of the building. After how many seconds will the object be 206 feet above the ground? So they're telling me to plug in 206 feet into this equation. And they want me to solve. So they're really saying to me, move this thing out of the way. They are really saying to me, get a different color. You know, 206, maybe it's right there. And how much time? That is an x value, but we'll use t because that's the letter they used. Okay, so 206, and we're trying to find that. Now, is there a linear t? Linear t. Nope. That means I can move this to the other side by subtraction. So, since there is no linear t, we can go ahead and do the method called square rooting. We're going to take the square root eventually. Alright, so that's going to give me negative 64 equals negative 16t squared. Of course, I'm going to divide out the negative 16. Give myself t squared equals positive 4. And now I take a square root, right? And t is equal to plus and minus 2. Which one of those solutions makes sense? Hopefully, you know that it would not make any sense in the world to be negative 2, because that would be 2 seconds before the object was dropped. So, the reality is, we only want positive 2. The negative is not applicable in this situation. So 2 seconds was the answer to the first part A. Now, the next thing it says is, after how many seconds will it hit the ground? Well, what are you going to use for the height of the ground? I'm hoping you're going to use the height of 0. Now, before you go subtracting 270 to the other side, which is a perfectly good method of doing this, I got another idea. What if we took this term and moved it to the other side, making it positive 16t squared equals 270? Didn't I just save myself a step because now I don't end up having to divide by a negative number? Well, I guess I still have to divide, so it's not like it's saving me a lot or anything like that. But it just looks nicer with only positives and no negatives. T squared equals, let's see, 270 divided by 16. Ooh, handy dandy calculator. That does not sound fun. 270 divided by 16. Not too bad, 16.875. And then we're going to take a square root of each side. And of course, remember the positive one is the only one that makes sense in this situation. And the square root of 16.875 is approximately, I'll use the approximately symbol instead of an equal sign, 4.11 seconds. And I think that is the end of this particular set of notes. Let me just double check. Yes, it is.